Okay, next topic, we are talking about our trig functions. I do apologize, I had all this stuff printed out for you. When you come next week, I'll be happy to give you a printed copy of a blank unit circle so you can transfer this over if you would like. I'm sorry I didn't have that to you before the past couple days. So just a couple things. In calculus, we are always going to use radian measure unless you are specifically told otherwise. So unless the problem is very clear that we are not, radian measure is the standard. And in order to do any of our calculations, we will have to convert things into radians. First thing I want to review is your unit circle. So I'm going to put degrees, radians, and ordered pairs on here. Your degree measurements, remember you have to put a degree symbol if you're talking about degrees. Start at 0 degrees, 30, 45, 60, and 90. Those are the common ones. If we jump down here, this line represents 180 degrees. And then we just subtract those reference angles. So 180 minus 30 is 150. 180 minus 45 is 135. 180 minus 60 is 120. Quadrant 3, we add them. So 180 plus 30 is 210. 180 plus 45 225, 180 plus 60 is 240, 180 plus 90 is 270. 0 degrees, you could also call that 360 if you like. So then we subtract our reference angle, so 360 minus 30 is 330. 360 minus 45, 315. And 360 minus 60 is 300. Okay, second thing, radians. 0 degrees is the same as 0 radians. 360 we could call 2 pi. Remember, you can convert to change degrees into radians. We know that 180 degrees is the same as pi, so we multiplied by pi over 180. And that reduces to pi over 6. So if you absolutely got stuck, you could certainly convert them by multiplying by the pi over 180 or 180 over pi if you were taking radians into degrees. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. Jump down here, 180 is the same as pi. Then we had lots of patterns for how to get the remaining part of this. You could, of course, just convert them. We could do pi minus each of the reference angles, pi minus pi over 6, pi minus pi over 4, and so forth. Or if you remember from trig the pattern in the quadrant 2, it's because of that subtraction, the numerator is always one smaller than the denominator. So this would be 5 pi over 6, 3 pi over 4, 2 pi over 3. Quadrant 3, it's like taking pi and adding your reference angle, so the numerator is one higher than the denominator. 7 pi over 6, 5 pi over 4, 4 pi over 3, 270 is 3 pi over 2. In the fourth quadrant, it's 2 pi minus your reference angle, so the pattern was double the bottom and subtract 1. So if 6 doubled is 12, minus 1 would be 11 pi over 6. 7 pi over 4, and 5 pi over 3. Alright, the next thing we added were ordered pairs. In those ordered pairs, the x represented cosine and the y represented sine. Okay, at this point, if we think this is a unit circle, this is 0, 0. So out here, this would be the point 1, 0. Cosine of 0 is 1, sine of 0 is 0. 30, remember your hand trick? So if you're looking at your hand, you can fold it, your fingers, your thumb represents 0, index finger is your 30, middle finger is your 45, ring finger is 60, pinky is 90. So if I want my 30, I just fold it in. Fold in your index finger, fold in your 30. The pattern was square root of the number of fingers over 2. So cosine is the bottom. I have 3 fingers below what I folded in, so cosine is radical 3 over 2. Sine is the top, radical 1 over 2, or 1/2. 45, if I fold in my 45, my middle finger, I have 2 fingers above and 2 below. So sine and cosine are both radical 2 over 2. 60, fold in your ring finger. Cosine is the bottom, you have 1 finger below, square root of 1 is 1, so cosine of 60 is 1/2. Sine, you have 3 fingers above, radical 3 over 2. 90, you fold in your pinky. Cosine is the fingers below, I have none below, so cosine of 90 is 0. Sine is the top, I have 3 fingers above, so that's radical 3 over 2. Excuse me, I have 4 fingers above. So square root of 4 is 2, divided by 2 is 1. Sine of 90 is 1. Okay, in the second quadrant, my ordered pairs are the same, except if you're in the second quadrant, your x is negative. So this one has a negative 1, negative radical 3 over 2, negative radical 2 over 2, negative 1/2, and all my y's should be identical. So 0, 1/2, radical 2 over 2, radical 3 over 2. Third quadrant, both x and y are negative. So same ordered pairs as their reference angles, except x and y are negative. Fourth quadrant, x is positive, but y is negative. And again, I apologize that I don't have that circle printed off for you to be using at home writing this down. Alright, so I just want to go through the definitions of our trig functions, talk about some graphs, talk about conversions, and just go through some examples here. So, a couple ways we can define these. We remember SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Remember, the other three trig functions were just their reciprocals. Cosecant's the reciprocal of sine, so hypotenuse over opposite. Secant, reciprocal of cosine, hypotenuse over adjacent. Cotangent, reciprocal of tangent, adjacent over opposite. Or we can use x, y, and r to define them. Sine is y over r, which means cosecant is r over y. Cosine, x over r, so secant is r over x. Tangent, y over x, so cotangent is x over y. So the first definition is what we used if we were looking at like triangles. Second definition was more useful if we were just looking at ordered pairs. Let's talk about graphs now. So sine falls between -1 and 1. These points are representing our quadrant breaks, so pi over 2, pi, 3 pi over 2, and 2 pi. And just think about our unit circle. Sine of 0 was 0. Sine of pi over 2 was 1. Then it went to 0 and -1. So 0, 1, 0, -1, and 2 pi is the same as 0, so you're back to there. Remember, these are nice smooth curves. Cosine is also between -1 and 1. Points pi over 2, pi, 3 pi over 2, and 2 pi. Cosine of 0 is 1. Pi over 2 is 0. At pi, cosine was -1. Back to 0 and up to 1. Nice smooth curves. Okay, tangent was kind of the weird one. We picked a different interval because of where the asymptotes fell. This was the one we graphed from -pi over 2 to +pi over 2. And these points represented your pi over 4s. Okay, tangent is y over x or sine over cosine. So tangent of 0 is 0 over 1, which is 0. At pi over 4, sine and cosine are both the same. Radical 2 over 2 divided by that same thing is 1. Pi over 2, you get 1 over 0. That's undefined, so we have a vertical asymptote. -pi over 4, it's like in quadrant 4, so tangent is -1. -pi over 2 is the same as 3 pi over 2. That's another vertical asymptote. So our graph looks like this. Okay, the remaining ones are the reciprocals. So cotangent's the reciprocal of tangent. That means anywhere tangent is 0, cotangent is undefined. So we pick a slightly different interval this time because I see tangent of 0 is 0. So that means cotangent of 0 is undefined. And on this one we went all the way to pi. Okay, at pi over 2, tangent was undefined, so that means cotangent is 0. At pi, if you do x over y, you get negative 1 over 0, which is undefined. Pi over 4, radical 2 over 2 divided by radical 2 over 2 is 1. 3 pi over 4, cosine is negative and sine is positive, so you're getting a negative 1. So it looks something like this. Secant is the reciprocal of cosine. A lot of times what I had you do is just lightly sketch in your cosine graph so you knew what happened here. So I'm going to draw my cosine graph in green. It's not really technically part of the secant graph, but it explains it a little bit. Then we think of the reciprocal of these points. Reciprocal of 1 is 1. At pi over 2, cosine is 0, so its reciprocal is undefined. Negative 1 would be negative 1. Undefined. And at 1 it would be 1. Then we just reflected these away from the x-axis, so it's actually looks like that. If the green throws you off, I always told you if you wanted to go back and erase those, you could if you needed to. Otherwise, as long as they're just lightly drawn in, it wasn't a big deal. Cosecant, reciprocal of sine. So we're going to lightly graph our sine to start. Okay, so sine of 0 is 0. Pi over 2 is 1. Back down. So there's our sine. So cosecant, reciprocal, high and low points stay. The zeros turn into asymptotes. It looks like this. Again, if you wanted to erase the green line, you could. You don't have to. All of these things are handy to have. If you have your binder, I would recommend putting this page kind of at the front where you will easily find it, so that throughout the year, if we have something talking about a trig function, you can quickly go look at this if you have forgotten anything. When I see you next week, I will give you the handout that had the blank unit circle and the blank pages for the graphs. I know it's not as useful now, but if you choose to copy it back over so you have it nice and neat in one spot, I think that would be a great idea. Now I just want to spend some time working through a few examples. Okay, first one's convert to radians. So 210 degrees. Now hopefully you just recognize this from your unit circle and you know what 210 degrees is in radians. You know, reference angle 30 in quadrant 3, and you should know that would be 7 pi over 6. If not, we can quickly work through it. You just have to multiply by pi over 180. The degrees cancel. And if you reduce that, you get 7 pi over 6. Alright, next one, negative 122. That one is not from the unit circle, so we have to work out the conversion. Multiply by pi over 180. Degrees cancel. 122 over 180, we want that as a fraction in lowest terms. And get negative 61 pi over 90. So they can be nice ones, they can be ones that we don't know off the top of our head. If I wanted to convert to degrees, we just flip it and multiply by 180 degrees over pi, because this time we want our pi's to drop out. So I take 11 over 5 times 180, and I get 396. Don't forget your degree symbol. 2 pi over 3 you shouldn't have to convert. When I see pi over 3, I think 60 degrees. 2 pi over 3 is quadrant 2. 60 degrees in quadrant 2, 180 minus 60 is 120. If you did forget, multiply by 180 over pi. Pi's drop. 2 over 3 times 180 is 120 degrees. Example 3. I want to evaluate these listing quadrant and reference angle. So, when I see this, 5 pi over 6, the numerator is 1 less than the denominator. That tells me quadrant 2. Reference angle, pi over 6, that's 30 degrees, or just pi over 6 is all you really need to write. So when I evaluate this, there are two things you have to look at. The quadrant tells you if it's positive or negative. If you remember, all students take calculus. In quadrant 2, sine is positive. That means cosine is negative. Pi over 6 is like 30 degrees. So if I'm using my hand trick, fold in my 30-degree finger, my index finger. Cosine's the bottom. I have 3 fingers below that, so that's radical 3 over 2. B. Cosecant of pi. Pi is right here. That's not really a quadrant, and I really don't have a reference angle, so I can't do either of those. If we think about this point on the unit circle, that's the point -1, 0. Cosecant is the reciprocal of sine. Sine is the y. So sine of pi is 0. That means cosecant is undefined. -7 pi over 4. You're welcome to deal with the negative. A lot of times we just added 2 pi first, so it was a positive. If you had a really big angle like 14 pi over 4 or something like that, you would subtract your 2 pi to get something that we usually see on our circle. So -7 over 4 plus 2 gives us a 1 pi over 4. So that's just quadrant 1. Reference angle is just pi over 4. In quadrant 1, they're all positive. Pi over 4 is like 45 degrees. If you fold in your 45-degree finger, that's your middle finger. Sine is the top, so that's radical 2 over 2. And one more. Cotangent of 7 pi over 6. So the numerator is 1 more than the denominator. That's quadrant 3. Reference angle is just pi over 6. In quadrant 3, tangent is positive, which means cotangent is positive. Pi over 6, if you fold in your 30-degree, your pi over 6 finger, that's your index finger. Tangent is the square root of the top over square root of the bottom. So cotangent would flip those. So square root of the bottom, so I have 3 fingers below, over the square root of the top, I have 1 finger above. And we just get radical 3. I have a couple examples left. I am going to go ahead and finish this today. Next piece I want to do is solving some equations. Alright, so on this one, if I ask you to solve this, you have to get cosine by itself. So add your 1. To get rid of a square, you add a square root. Anytime you do that, it's plus and minus. So cosine theta equals plus and minus 1. You're trying to tell me theta. Theta is just the angle where cosine is 1. If you think about your circle, cosine is the x. So we can see it's 1 here, and it's -1 here. So I'm getting 2 answers. 0, which is the same as 2 pi, or pi. I asked you for all possible solutions though. What happens is every time I go around the circle and I come back around, I'm going to hit that again. So if I say all possible solutions, we have to put plus 2 pi k. Where k is an integer value. Meaning k could be -2, -1, 0, 1, 2. This could be written a couple different ways. 0 plus 2 pi k is just 2 pi k. So you could give me your answers as 2 pi k and plus pi plus 2 pi k. Or on this particular problem, you could even say just pi k. It happens every multiple of pi. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. I'm not going to be real picky on these. As long as you have one of the equivalent answers, that's fine. I'm not going to stress about making sure you have the most concise way of writing it. Alright, B. We need to first get our tangent by itself. So I will subtract my radical 3, and then I will divide by 3. Okay, I need to think about quadrants and reference angles. All students take calculus. Tangent is positive in 1 and 3, so it's negative in 2 and 4. Reference angle. If tangent is radical 3 over 3, you can use your hand trick, figure that out. Tangent of 0 is 0. Tangent of 30 is radical 1 over radical 3, which is radical 3 over 3. So my reference angle is pi over 6. Pi over 6 in quadrant 2 is 5 pi over 6. Quadrant 4, double the denominator minus 1, 11 pi over 6. Because I said all possible solutions, you have to do the plus 2 pi k on each of those, where k is an integer value. We don't want a fraction. All right. And very last example. Okay. This time I'm only solving between 0 and 2 pi. So that tells me I have a stopping point. We don't have to put the plus 2 pi k this time. Because I have both a sine squared and a sine, I can't just get the sine by itself. But what I could do, looking at those two terms, we could factor out a sine theta. So two things multiplied equal 0, so either sine theta equals 0 or 2 sine theta plus 1 equals 0. Okay, if sine is 0, think about your unit circle. Sine is your y. That happens at 0 and pi. Now 0 and 2 pi are technically the same, but because in my interval I put the bracket on the 0 and just a parenthesis on the 2 pi, use 0 in this scenario. This one, if I solve for sine, subtract my 1, divide by 2, sine theta equals -1/2. All students, sine is positive in 1 and 2, so it's negative in 3 and 4. Reference angle, sine is a half at 30 degrees, pi over 6. Pi over 6 in quadrant 3 would be 7 pi over 6. In quadrant 4, that would be 11 pi over 6. So this one had 4 possible answers. Okay, so that is the end of topic D, our trig review. I am not giving you any homework over this right now. Monday, I will have a handout for you. Those of you that are in class I will give you the physical handout. Those of you that are not, I will be posting it on Classroom. I will probably also make a video or even do a Google Meet if anybody wants to join our class live, just discussing a little bit about what things are going to look like while we continue on this hybrid schedule. So Monday, we'll have homework over this, and then we're going to be discussing a little bit about our plan moving forward. Please, guys, don't hesitate to contact me if you have any questions or concerns, and have a great weekend.